So if you were going to start with a photograph, I want you to work as a table group now and just generate the questions that you yourselves want to ask about the image in the photograph, and particularly obviously from a mathematical point of view, but what questions would it generate, and maybe what work or problem solving could come out of these photographs.
Just choose one.
Choose one, yeah. Right, Pau, what do you think? Starting with a photograph.
It's surprising how much you can get out of it.
It's surprising what you can get out of a photograph. Could you now take some photographs around your school and challenge the children then? Yeah. On a quiet day, yeah. I mean, I was working with a school and they've had their whole grounds redeveloped. It's very much an urban school, so there's yard rather than field. But a whole new school has been built, and a nice sort of big wall. And I just challenged the children. How many bricks do you think they used to build that wall? Now, it's 20 foot high. We're not going to send a child up a ladder going 1, 2, 3, 4. But it's how could we find out? And it was like, well, I could count all the ones I could reach. Yeah, okay, so off you go, do that. I wasn't saying, yeah, but is there a better way? It's like, yeah, go on, go and count all the ones you can reach up to a certain level. That's fine. They have to go through the experience. We don't want to almost close down that learning with there's only one way of doing this. We want them to find out. And I said, well, what about the ones you can't reach? And they had a little talk together. And it's like, well, if we know that amount, if we doubled it, it will be up there somewhere. And it was like, well, that's a bit vague, the up there somewhere. And then they decided that if they took photographs, because they all had iPads in this school as well, but using the iPad to take a photograph of the bricks they could count, and then they cut and pasted and repeated the paste to see how many, and then they were into multiplication. So in terms of rich evidence of problem-solving skills, investigation skills, and then application of numeracy skills, to then tell me, da-da, we found out how many bricks are in there, give or take a few. So it is harnessing what we've got, making use of what we've got, to then put into our maths lessons. You've all been very, very good in the sense that you haven't had a rummage in the box on your table or the pretty carrier bag on your table. But often I work with children and I say to them, our maths lesson today is going to come out of the box. So it's the what's in the box approach. And it's like, you know what's in the box because you've put it in the box. But they might also just like sit in a circle, what's going to be in the box today? Or someone is chosen to take the something out of the box or out of the bag. And it just puts that element of, ooh, I wonder what's going to happen in maths today, to make maths exciting right from the start of the lesson. So what's in your box? Would you very carefully get out? Sorry, I'm treating you like children now, sorry. Would you like to get out of your box?
They're not in boxes.
Or bags, a box or bags, some digit cards, okay? Now I'd like to also draw your attention to the handout, and the front page on the handout is how I'd like you to work when you're engaging in the activities today, generally, not just now, but generally. If you can work in groups of 3 or 4, that's fine. It should be in your pack, the handout. So what I'd like you to do is a couple of you to have a go at the activities and one person to be in the role of look, listen and note, the observer. And we'll swap your roles over, so you're not the observer all day. And what I'd like the observer to look out for is learning. What learning is being demonstrated in solving these problems, in working in this way. And that's when you can refer to the problem-solving strands and the numeracy framework in terms of what skills are being demonstrated in the learning. I just want to demonstrate to you the idea of digit cards. Are you familiar with digit cards or number fans? Yeah, that you might use in your classrooms. So you're asking questions. Yes, you can ask open questions as well as closed questions. You're familiar with that. But it's how we want children to respond. It's setting up that expectation. So if I said to you, show me an odd number, so on your number fan or your digit card, show me an odd number. If you just show it to me, No one's joining in. I'm feeling very lonely at the front here. Can you show me an odd number? Thank you. If you just show it to me, I can just go, yeah, right. If I said to you, I want you to tell me in a sentence what you're showing me, 3 is an odd number. So show me an odd number. What are you showing me? 1 is an odd number.
5 is an odd number.
So you're responding through showing, say, and display, essentially. You're saying and displaying. But the minute you are saying it, it's helping you understand about odd numbers. So show me a number that's greater than 10. Show me a number that's greater than 10. And I'm going to set you up for the expectation that... That's freaky, you're talking about the same numbers. So how would you now respond?
I know that 12 is greater than 10.
12 is greater than 10.
13 is greater.
Yeah. So I'm clarifying all the time, 54 is greater than it. So the expectation that you will show me and you will also respond in a complete sentence to embed that learning. Yeah, so again, you can just take a few responses from children. It's not going to slow down the pace of that recall part, but it's just clarifying learning. So show me any prime number you want to. Any prime number you want to. Everyone's playing safe. Ooh, freaky. Okay. 23 is a prime number. And another prime number.
13 is a prime number.
And another prime number. At the back there. She's waving. 7 is a prime number. Right. And another prime number. 3 is a prime number. What do you know about prime numbers?
You can divide them by the number of parts and themselves and 1.
Okay. You can divide them by themselves and 1. So what that means, how many factors does a prime number have? 2. I want to get that language in. Children are happy with the word multiple, but they don't like factors for some reason. Yeah? Okay? So setting children up to expect them to answer in a complete sentence, to give back the question, essentially, in their answer. Okay. Counting is easy, isn't it? Do you count with your children in Key Stage 2? Yes. Backwards as well as forwards? Because we all have a natural aversion to subtraction. Okay, we're going to do some counting today, so bear with me. You're going to join in. To start with, this group are going to be counting in ones. The middle, phew, steady, steady. This group, 3 down the middle, are going to be counting in tens, and you 3 down the side are going to be counting in hundreds. Okay, we're going to start at 195, and we're going to count in ones, and we're going to count on. So 195,
196, 197, 198, 199, 200, 201, 202.
Stop. We're carrying on. You've got to 202, and we're counting in tens, and we're counting on. 202,
212, 222, 232, 242, 252.
stop. 252, we're counting on in hundreds.
352, 452, 552, 652.
Stop. 652, we're counting backwards in ones. 652,
651, 650, 649, 648, 647.
Stop. 647, counting backwards in tens. 647,
637,
627,
617,
607, 597, 587. Stop. You get the gist. Deliberately going over those tens boundaries and those hundreds boundaries. These 3 tables here, we're going to be counting in tenths, but we're going to be counting in 0.1, 0.2, 0.3, not in the fraction tense, the decimal. Okay. We're counting in ones here, and we're counting in tens over here. Okay. We'll count on to start with. Let's count in tens, starting at 83. 3, 93, 103, 113. Stop. 113, counting on in tenths. 113.1, 113.2.
113.3, 113.4.
Stop. 113.4, counting on in tens. 113.4. Ones. Sorry, thank you. 113. They're the tens. 113.4. 114.4. 115.4.
116.4.
Stop. We're going to count backwards in tenths. Where were we?
116.4.
Backwards in tenths.
116.3, 116.2, 116.1, 116, 115.9, 115.8.
Stop. You get the gist. Counting is easy. Do you do that kind of counting with your children? Using a lot of reasoning about your numbers, what comes next, what comes before, but pushing it into thinking. Really, you had to think then, particularly when we went into the tenths, isn't it? So think about how you can make counting more challenging in your classroom then. Okay, what's in the box? In the box is something that I call a logic grid. And the logic grid, there's some posters up on the side of the wall as well. What you've got is a series of clues in your logic grid. And you've got some answers as well. Now, how I introduce this to children is, here are the clues, and I talk about each of the clues and what could the answers be. And they tell me all about what the answers could be, what they know. And then I get the little answers out, and they have to then match the answers in each of the cells. Now, some answers could go in many of the cells because there are open and closed questions in the logic grid. But when they've worked it all out, one sits very nicely in each cell. Now, again, it's setting children up for this speaking expectation. I do not accept that goes there, that goes there, that goes there, done it. I challenge them. Why does 3 go there? Well, 3 goes there because, and they have to justify their reason of why they've placed the number or the shape, for example, why it has to be there. So, I'd like you to have a go at the logic grid. You're all doing it now. Who's looking and who's listening and who's noting down the learning? Swap over, okay? And I don't want you to do it, that goes there, that goes there. I want you to talk about what you're doing. So, person doing look, listen and note. What were you observing? I have used this with children in a group situation where there's been perhaps 3 or 4 children solving this together on a nice big piece of flip chart paper where they're on the floor and they have to physically move the post-it notes around, and they love doing things like that. But what I've done is I've left just sort of like an MP3 or a recording device to listen to later, because sometimes as a teacher, when you stood next to the children, they don't open up, or they just wait for you to put words into their mouths almost. So it's like, here's the activity, I'm setting it up, I'm walking away. But it's how children get used to your expectations. So things like setting up the MP3, they're used to, it's going to be recorded. So it's setting up those expectations. Okay, there's just a question on the board. Odd one out I love doing, because it can be any number, as long as you can mathematically justify why it's the odd one out. But this bottom one is of more interest to me, because if I was doing something on the Tudors, a history project on the Tudors, rather than seeing maths and history as just purely a chronological link, putting things in date order and when things happened, how about that as a problem? Could your great, there are 5 of them, 5 greats, grandmother have met Queen Elizabeth I? Talk to the people on your table. How on earth could you work that out? Could she have?
250, no.
Some people saying no, some people saying yes. It's no right or wrong answer, because it depends on... yeah. And that's quite challenging in maths, in a sense, because children are led to believe that there is one right answer. In some instances, there is one right answer. But in other instances, there could be a variety of answers. But it just is a much better question in a historical context, isn't it? Much better. Okay, dive in your box again, not literally. What's in your box? You're looking for a set of number grids that says questions for number grids. Key space, you have raided your box.
I thought solid.
Yeah. So you've got a set of 3 grids. And how I work with children on these grids, whichever grid they might use. So it might be a 0 to 9 grid, depending on the ability of the children. It might be a 2-digit number grid, or it might be a 3-digit number grid, or it might even be a decimal number grid as well. But the important thing, before we can even start the problem-solving bit, almost, we need to practice how to do the activity. Because I'm teaching how to do the mathematics, how to do the activity, and how I'd like children to record. So it might be that they've got the number grid. They've never had a number grid in their life. Okay, so they're dead excited they've got a number grid in front of them. And I say to them, right, you've got 2 plastic counters. You can put them anywhere you want. And I want you to investigate the sums that you make. Sum meaning add. Okay, refining that language. So what different sums can you make? And then I might let them explore, okay, 2 counters. What subtractions can you find, or what differences can you make? So they're exploring what's the sum, what's the different. So that could be one lesson where they're exploring that. So they're learning how to calculate. Might be recall of their number facts. It might be reinforcing a calculation method that they've been learning. Lesson 2 might be, okay, you can put your counters anywhere you want to, but the sums have to be an odd number, or the differences have to be an even number today. A little bit more reasoning. So they practice that. And then the 3rd day, they get their number board out again, or what are we going to do with the number board today? And you've got a series of questions on the paperclip in the pack there. Can you work through some of those questions? Using the number grid and using 2 counters, you need to choose 2 numbers and you've got some questions to answer. And it's 2 different numbers each time if you want. Again, work in 3s, 1 person to look, listen and note the learning that they can see happening. Same but different then. Another kind of target board. And another kind of target board where you've got money and coins. So again, you would explain to children how the activity works by placing, this time, 3 counters and exploring maybe the totals you can make. You can keep changing the rules. Now you've got the target board, you can keep changing the rules over and over again. But it might be this time that... Excuse me, thank you. That's all right. I like excited chatter about maths, don't worry. It might be this time that you can say, because they've explored, say, the totals they could make. They've got 3 counters. Today, every total has to be more than 500. Or the totals have to come between 600 and 750. So you're giving them parameters. Or it might be... for example, I placed 3 counters on my money target board. I won £3. Where did I put the counters? So you just got a bit of a twist to that question to make it more problem solving and more reasoning in the children's thought and the thought process they have to go to in order to answer the question. That's just something else that you might want to explore in your own time. I'd like to show you, I love game show mathematics. Now, there might be some people in the room, me included, who are old enough to remember Play Your Cards Right. I'm not sure if it's still on the television, but Play Your Cards Right meant that a number was revealed and then the person who was in the competition had to predict and guess, was the next number going to be higher or lower than that number? I'll give you a clue. The numbers are all less than 2. All right? So, looking at 0.2, is the next number going to be higher or lower than 0.2? Higher. Yes, yes. Children will cheer at anything. So you need to clarify. So is 1.9 actually higher than 0.2? By how much? Okay, lots of those clarifying questions. Right, the next question. 1.9. Is it going to be higher or lower than 1.9? Lower. Lower than a 1.9? Hooray! 0.5, 0.5. Is it lower than 1.9? Yes. How much lower is it? Okay, the next one, the final one. Higher or lower than 0.5? Higher. Higher! Yay! That's it. You won a holiday, a car, all sorts of things. Excellent. But those sorts of things get children thinking, predicting. They get them engaged with the mathematics. Do that maybe as a mental starter with the children. If you've been working on decimals, it then links nicely to decimals. We've done number grids. Sometimes, always, never true. I've given you some examples in your handout, just statements to explore with children. And they've got to prove whether it's sometimes true, always true, or never true. Squares have 4 sides, so shapes with 4 sides are squares. Sometimes true, always true, or never true. Doubling a number will make it bigger. Sometimes true, always true, never true. It's setting the children up to engage with the mathematics, to have that dialogue, but then to prove and to reason, to give you a counter-argument, if you like. I'd just like to finish with a couple of questions, again, based in history. A servant in Victorian times might have earned £20 in a year. What could you buy now for £20? Exploration. Maybe what do you need to buy versus in Victorian times, what did they need to buy in terms of priorities? But what about the lamplighter problem? Lamplighter in Victorian times would light the street lamps an hour after sunset and then put them out at midnight. For how many hours did the lamps burn in September, in October, in July? Have a discussion as to how you would go about that.